Greetings, I'm Dev the developer.
And I'm Glitch.
This video is about polymorphism. By the end, you will be able to put every employee type in a single list and run payroll with one loop, no matter how many different types are in there. We have been building the hierarchy to get here, and this is the payoff. So, before we get into the good part, let me show you the problem we are actually solving. You have got the employee hierarchy from the last few videos, the hourly employee, the salaried employee, and the manager. Glitch, pull up a new file and show me how payroll would look without polymorphism.
Okay, so this is the setup, 3 lists, 1 per type. Now to run payroll, I just loop through each one. Done, 3 loops, everyone gets paid, works perfectly.
It works. What happens when you add contract employee type next month?
I add a new list for it and another loop at the bottom.
In every place in the program that processes employees, the payroll output, the annual report, the CSV export, each of these gets a new list and a new loop.
Okay, yeah, every place, every time, that does scale badly.
The root of the problem is that you have 3 separate lists when what you actually want is one list of employees. Here's the key insight. You can have that because hourly employee, salaried employee, and manager are all employees. That relationship is load-bearing.
Wait, so a relationship we got from inheritance means they can go in the same list.
That's exactly what it means. Try it. Delete all 4 lists and start over with one.
Okay, one list to hold all of them, the type would be, I need something they all have in common. Let me try object. Every type in C# inherits from object, so they would all fit. There, one list, all 3 types fit.
Now write the loop.
The editor does not like that. Name and calculate pay are underlined in red.
What type does the compiler think emp is?
Object, because I declared the list as a list of object. So when I loop through it, emp is object, and object doesn't have name or calculate pay. Those are on employee.
Right. The declared type of the variable controls what members you can access. Object knows almost nothing. You lost all the employee-specific members the moment you declared a list of objects.
So object is too broad. I need something with name and calculate pay, which is employee.
Try it.
No red squiggles on the list setup. Let me check the loop too. Clean, so employee emp in the loop gives me access to name and calculate pay because those are defined on employee. But wait, all 4 objects in that list are different types. When emp is Alice, it's actually an hourly employee. When the loop calls calculate pay through an employee variable, which version runs?
Which version do you think runs?
I mean, the right one, hourly employees version, but the variable says employee. So does C# use the declared type or the actual type?
The actual type, always. For virtual and abstract methods, C# looks at what the object actually is at runtime, not what the variable claims it is, and dispatches to that version of the method. It does not matter how the variable is declared. The object knows what it is.
Oh, so the variable type is for the compiler. It determines what calls are legal, but the runtime does something different. It looks at the real object and says this is actually an hourly employee and runs that version.
That is it exactly. Run the loop and watch the output.
Wait, Alice is $0. Is that wrong?
Is it? Think about what hourly employee.calculatePay does.
It multiplies hours worked by hourly rate, and hours worked is 0 because we never set it. She didn't clock any hours. That's not a bug. That is hourly employee doing exactly the right math with the data it has.
Right. The dispatch worked correctly. The output is accurate. If you want Alice to be paid, log her hours first.
That's actually a good point. The problem is the data, not the dispatch mechanism. Okay, so we have one loop, 4 different types, and each one runs its own version of calculate pay. That's polymorphism.
That is polymorphism. The word comes from Greek poly for many, morphe for form. One reference, many behaviors. The same method call dispatched differently based on what the object actually is. The mechanism that makes this work is called virtual dispatch or dynamic dispatch. Late binding. The bindings between the method call and the implementation is resolved at runtime, not at compile time.
Wait, so regular method calls get resolved at compile time?
For non-virtual methods, yes. The compiler sees a declared type, looks up which method matches, and hardwires that connection. It is done before the program ever runs. Static dispatch. Early binding. For virtual and abstract methods, that connection stays open. The runtime makes it at the moment of the call based on the actual object. That's the difference.
Okay, so marking a method virtual or abstract in the base class is what turns on late binding for that method, not the variable declaration, not the call site, the method itself.
Exactly. And calculate pay was marked abstract on employee in the first video of this series. Every derived class overrides it. That's all it takes. The loop we just wrote didn't do anything special. It just called a method on a base type variable and the runtime handled the rest.
So the power was already set up in the class hierarchy. The loop just takes advantage of it.
Now think about what happens when you add contract employee next month. What has to change?
Just write the new class, have it inherit from employee, override calculate pay, and it automatically gets picked up by the loop. You do not touch the loop. You do not touch anything that already exists.
You extend the system by adding to it, not by modifying what is already there. The loop is stable. The payroll logic is stable. The new type is the only thing that changes. That is why polymorphism is worth understanding at a deeper level than just, it's a pattern.
That's actually kind of significant. The system adapts to new participants without any of the existing parts needing to know they arrived. A new type just implements the contract and the whole infrastructure starts calling its methods. The existing callers never see it coming. They just start dispatching to it automatically.
That's a very thorough description of a software design principle.
I was describing the open-closed principle. It's a software design thing.
Right, it is. Let's talk about interfaces. Everything we have covered applies to interfaces too. In the last video, you built IReportable with a getReport method. Every concrete type implemented it. Let's see what that enables.
R is declared as IReportable but holds an hourly employee, then a manager. Each call to getReport runs whichever class's version is behind the reference at that moment.
Same dispatch mechanism. The reference type is the interface, but the runtime still looks at the actual object and calls the class's implementation.
Wait, so is there a difference between base class polymorphism and interface polymorphism, mechanically?
The dispatch mechanism is the same. The difference is what the reference can see. A variable declared as employee gives you access to everything on employee. Name, calculate pay, whatever else is on that class. A variable declared as IReportable gives you access only to what is on the interface, just getReport. But both dispatch to the correct class implementation when you call a method.
So the narrower the reference type, the less you can see through it, but the dispatch still works correctly for whatever is behind it.
Right, and that narrowness is often the point. The most common place you see interface polymorphism is in method parameters.
So print report accepts any IReportable. It doesn't know or care what actual type comes in. It just knows getReport is available.
And it works for anything that implements the interface.
And if commission employee implements IReportable, that works too, without changing print report.
Once that method was written, it works for types that did not exist when you wrote it. That is what the interface contract buys you. The method author made a promise. Give me something with getReport and I can work with it. Any type that keeps its half of the promise gets to use that method.
Okay, so base class polymorphism requires sharing the same inheritance chain. Interface polymorphism just requires implementing the same contract. The dispatch mechanism is the same either way. What changes is how you get to participate.
Exactly. And you can have both at the same time. Hourly employee inherits from employee and implements IReportable. A list of employee loop can dispatch calculate pay polymorphic. A print report can call dispatch get report polymorphically. Same object, two different polymorphic paths, depending on how you're looking at it.
That's actually a lot of flexibility. One object participates in multiple dispatch chains depending on which reference type you're using to look at it.
Which brings us back to why the opening setup was wrong from the start. 4 separate lists, 4 separate loops. You had 4 different types that all share an inheritance chain. The language was already offering you a single list and a single loop. You just had to declare the list with the right time.
A list of object was too broad. A list of hourly employee was too narrow. A list of employee was right. It captures what they all have in common without losing the dispatch behavior.
The declared type of the list determines what you can call on each element. Employee gives you name and calculate pay. The runtime takes care of dispatching to the right version. That combination is exactly what you need.
One reference type, many behaviors. The caller never needs to know what it's actually talking to. The system dispatches. The specific implementation is none of the caller's business.
That is the design. The caller operates at the level of the interface or the base class. Everything below that is encapsulated in a specific type. Complexity is still there. It is just organized so the caller never has to deal with it.
Oh, that's the pattern. Complexity doesn't disappear. It just moves to where it belongs. Once you see that, the 3-line payroll loop stops looking like a trick.
The payroll loop is not magic. It is just a well-organized system doing its job. 3 lines because every piece of complexity is already in the right place. Try building it yourself. Create the employee classes from scratch, put them in a list of employee, and run one loop to print the pay for each one. Then add a new type and verify the loop doesn't need to change. Don't just watch it. Do it.